thermometer. Then we have temperature. Okay. Then we have heat. Then we have thermal equilibrium. Okay, which is very close to one another and always exists in the thermal topic. So basically, we use this thermometer to measure the temperature. Okay, and temperature, there are 3 different scale of temperature. So that we learned. So far we learned 3. So one is degrees Celsius, then followed by degree Fahrenheit and Kelvin. The scale from degree Celsius to degree Fahrenheit, from degree Celsius to degree Fahrenheit, from degree Celsius to Kelvin, and also from Kelvin to degree Celsius. Okay, so how we do this kind of conversion? So we refer to this expression where the temperature in Kelvin is equal to temperature in Celsius plus 273 or 273.15. So many students ask me, should I use 273 or 273.15? So it depends on the constant value given, right? If the constant value is given as 273.15, then we use this. Okay, if the constant value is given as 273, then we use 273. If the constant value is not given, both we will accept. We will accept both, don't worry. Okay, then the temperature in Fahrenheit. So how can we convert the temperature in Celsius to temperature in Fahrenheit is 9/5, temperature in Celsius plus 32. So if you want to change from Fahrenheit to Celsius, you may refer back to the same expression. Okay, refer back to the same expression. And the change of temperature in Celsius is equal to the change of temperature in Kelvin. So bear in mind that temperature in Kelvin is not equal to the temperature in Celsius. And the change of temperature in Fahrenheit is equal to the change 9/5, the change of temperature in Celsius. Okay, so basically you just need to remember these few expression for you to get the change of temperature or convert from one scale to another scale. Okay, look at here, there's no direct conversion of the scale from degree Fahrenheit to Kelvin. So what you need to do, you have to convert to Celsius, then go back to Kelvin. Okay, then after that, if temperature increase, okay, what happened? Have the expansion. So expansion, we can have 1, 2, and 3 dimension. So we have a linear expansion. Right, so linear expansion means we refer to the change of length is equal to alpha L naught delta T. Okay, we also have the area expansion, where delta means a change. So whenever you see the symbol of delta, we are using the final A minus the initial A. Or we use the final minus initial. So it's equal to gamma A naught delta T, where gamma is equal to 2 alpha. Right, so we also have this for that 3 dimension volume expansion, where delta V is equal to beta V naught delta T, where beta is equal to 3 alpha. Right, this alpha, gamma, and beta is a coefficient of the linear expansion, area expansion, and volume expansion respectively. All right, so this is the expansion due to the increment of temperature. Then after that, right, so when we talk about heat, right, this heat here. So what is heat? Heat means heat energy, right? So heat energy means it is energy, right? Heat is a form of energy where the unit of the energy could be written in calorie or joule. So in our lecture here, usually we will refer to joule because joule is the SI unit for heat, right? And calorie, 1 calorie is basically equal to 4.186 joule. So you can also set it in calorie, just to let you know that the relation between the joule and calorie. So heat here, heat, we can state the heat, we can refer to the specific heat. Specific heat, specific heat capacity, small letter of C, which is defined as the heat required for every 1 kilogram of substance to change its temperature. So again, this is a delta. So where delta T is equal to T final minus T initial. Because I look at this triangle means I always use final minus initial. All right. So Q can have a positive Q or negative Q. Positive heat or negative heat. Positive means it supply the heat to the system, supply Q to system. Negative means is Q is removed from system. All right. So if you use a delta T and you'll find out that this Q, you may get it Q as positive or Q as negative. That's how you define whether Q is released from the system or Q is supplied to the system. So the other heat is called it as latent heat. Latent heat, we use a capital letter of L. It is defined as a Q, the heat required to change the phase of every 1 kilogram of substance at constant temperature, right? Constant heat. There's no change of temperature, right? So the latent heat here, we can also have, there are 3 types of latent heat. 1, 2, 3. So latent heat of fusion, latent heat of vaporization, and latent heat of sublimation. So what is a latent heat of fusion? So latent heat of fusion means when the phase involves solid and liquid. Vaporization means we refer to the phase, the changing of phase that involving a vaporization, liquid and gas. Sublimation means it's a change of phase when it involves the phase of changing from solid and gas. Right? Then only you know that which latent heat that I should use: fusion, vaporization, or sublimation. All right. So this is heat. Then heat can be transferred. So when heat transferred, heat is always transferred from high temperature to low temperature. It will reach a condition called it as thermal equilibrium, right? Thermal equilibrium. So thermal equilibrium here means we assume that there is no loss of heat. Q absorbed is always equal to negative Q release, right? So remember to add a negative here. Negative Q release. So this is release. Negative Q release. All right. So what is a Q absorb? So maybe this Q you can refer to Q equal to MC delta T, or you can also refer to Q equal to ML. So this ML here can be positive or negative. So when we apply Q equal to ML, you have to know that whether the Q is absorbing or releasing the energy. If it is releasing the energy, directly add the negative to the L, right? Because M cannot be positive, cannot be negative, right? Directly add a negative to the L. But here, if you're applying this, we do not need to add the negative to the Q, because delta T will tell you whether it is releasing the energy or absorbing the energy, all right? Because we always use final minus initial. If final is less than the initial, then delta T will automatically get a negative value. Therefore, Q also negative. If Q is negative, then the Q release here will be negative. Negative multiplied with negative, you will get a positive value, right? Heat can be transferred, okay, through via a few mechanisms. Okay, what are the mechanisms? Mechanism of heat transfer. Then we have to refer to what are the mechanism of heat transfer. So mechanism of heat transfer. So we have 3 mechanisms that we learned so far. That is, the first one is called as conduction. Okay, conduction means that is a direct physical contact, okay, from the source of the heat to a particular object. So this conduction is due to the vibration of molecule, right? So when the rate of heat transfer, so Q over delta T, rate of heat transfer, or sometimes we call it a power, is equal to Ka delta T divided by L, where K is called as thermal conductivity. Different material has a different value of thermal conductivity. Okay, so usually for metal, it has a high value of thermal conductivity. So based on here, the rate of heat transfer is proportional to the thermal conductivity. Rate of heat transfer is proportional to the cross-section area. It's proportional to the temperature difference. Okay, this delta T here, we don't use final minus initial. So this delta T here, we use the high temperature minus the low temperature. Okay, because the heat is transferred, we are referring to heat transfer. Heat always transfer from high temperature to low temperature, and this rate of heat transfer cannot be negative. So that's why you use a high temperature minus a low temperature. L here will be the distance or the thickness of a wall. Okay, that is the conduction. And the second mechanism of heat transfer is called as convection. Right? So this convection is basically due to the movement of the molecule in a fluid. Movement of a molecule within a medium or a fluid. So the fluid here can be liquid or gas. Right? For example, when you boil water in a pot, right? So inside the water, there is a lot of fluid, right? So that's how the heat can be transferred. Okay, this is a pot of water. and there's a water here. So at the bottom here, the molecule is very hot. So warm molecule will go up and cold molecule will go down, right? Warm up, cool down, warm up, cool down. Okay, warm molecule go up is due to the density. So why there's a movement? Due to density difference. Density difference. Okay, so basically hot molecule or warm molecule, the density is lower. So that's why go up. Warm up, cool down. All right, that's how you heat up the entire pot. Entire water in the pot here. Okay, the third, there's no calculation for the convection. So the third mechanism is called it as radiation. So the rate of radiation is power is A E sigma T power of 4, right? So if an object is at temperature T and it is able to radiate the heat due to the temperature T. So radiation is via the electromagnetic wave, right? Electromagnetic wave. So at the same time, you place the object at the surrounding at temperature T naught. So this surrounding here which has a temperature of T naught, it will also radiate the energy towards to the object. And therefore, we can find out the net radiation, which is A E sigma T power of 4 minus T naught power of 4. So again, the A E sigma T minus T naught power of 4 is wrong. Okay, so please bear in. So this is the mechanism of heat transfer.